For this example, we're looking at some data of 6 people who tried a brand of sleeping pills and the number of minutes it took them to fall asleep. So the data is given to us, and there are 6 values listed here on the page. The question asks us to find a 90% confidence interval for the population mean number of minutes it takes to fall asleep. In other words, we're trying to find a range of values in which we think the average person would take to fall asleep using this sleeping pill. To construct this confidence interval, we use the same formula as before, in that we're taking the sample mean and adding and subtracting a margin of error. But this problem is a little bit more tricky because none of that information is given to us directly. We are looking for a sample mean, but it just gives us the 6 data values. So we can calculate our own sample mean. So I took my 6 data values, summed them up, divided by 6, and got a sample mean of 25. Onto the margin of error, I need to find the sample size, which is n equals 6, and I need the sample standard deviation, which is 9.59. But you'll notice again that value is not given to us in the problem. So what I had to do is I had to calculate my own sample standard deviation. So this is almost like a real-world problem, where we've gone out, we've collected data, and we're creating our own confidence interval from scratch. I computed my own sample mean, and I'm going to compute my own standard deviation for the sample as well. You see here on the right side, I've decided to use the computational formula to compute the standard deviation. So I need to know the sum of all my x values, my data, and also I took those values and squared them and got the sum of x squared. Using the computational formula, which we learned back in chapter 3, I computed our standard deviation for this problem, which came out to be 9.59. Going back to my margin of error, I'm going to utilize that standard deviation along with the sample size, which is 6, because there's 6 data values. And the last thing I need is my critical value. So again, here I'm going to use the student's t-distribution. I'm using that because sigma is unknown, and I'm using the sample standard deviation in my calculation instead. In order to find this critical value, I'm going to use the student's t-table again. And before I use it, I need to know what the degrees of freedom are for this problem. The degrees of freedom being n minus 1 gives us a value of 5 for this problem. So I'm going to go to my table with a confidence level of 0.9 and a degrees of freedom of 5. On the third row, I'm going to look up my confidence level of 0.9, and I'm going to look up my degrees of freedom of 5 in the leftmost column, and I'm going to match up that row and that column, giving me a critical value of 2.015. That's the value I plug into my formula to calculate the margin of error. This gives me a margin of error of 7.89. Taking that margin of error and adding it and subtracting it from the sample mean gives me my final confidence interval here. You might notice that my confidence interval is quite wide, and I'm only actually 90% certain that the average amount of time it would take a person to fall asleep is between 17 minutes and almost 33 minutes. A lot of the problem with this experiment is that my margin of error is quite large because my sample size is quite small. If I had the same data with a much larger sample size, I would probably have a much smaller margin of error and a much narrower range for my confidence interval.